Don't accept.
Hi everyone, this is Ryan Corcoran with Broadcast Buddy TV, the all-around go-to channel for all things broadcast television. Where here on the channel, it is our goal to equip you with the tips, tricks, and know-hows to help make you a better broadcaster. So if you're new to the channel, please consider subscribing and hit that bell icon so you never miss an upload. With that being said, we are somewhere different today. As you may have noticed, we are actually at my office. And the reason we're doing this is because I wanted to try something a little new. I wanted to essentially walk through with you guys one of my projects that I'm working on that I like to call a shader in a box. So if you do like this format, make sure you let me know in the comments, and if you want to see more of that, we can certainly accommodate for that. So anyways, let me walk you through a little bit here what we're going to be doing. We have essentially 5 of these JVC HM890 controllers, the LP20 remote control units by Pro HD. And what we're going to be doing is we're going to try to take these 5 remote control panels and mount them into this Pelican Air fly case. It is the 1555. We'll put that up on the screen. And I bought this bad boy off of Amazon, and of course I will include the links to all of the products and parts that you see throughout this video in the description below. So essentially we're going to do that, and we're also going to be trying to mount a Marshall VR173DLW monitor in the lid of this as well. So the concept is we want to be able to take this case and just plop it down, open it up, and have access to our remote control panels and start doing our cameras, because the CCUs, the camera control units for this, are going to be going into a fly pack, and we want this to be as mobile as possible. So why don't we take a few minutes here and we'll go over and I'll kind of show you my concept here, my theory of how I want this to work, and then we'll go through the process of putting it all together. Hey everybody, Future Ryan here. So I wanted to preface this video with 2 things. The first was that this was definitely not a single day project, and you will see multiple wardrobe changes throughout the entire video. The second thing is I'm sure there are 101 different ways that this project could have been approached, but I am curious, as you're watching, if there is something you would have done differently, make sure to let me know in the comments below. And with that, we'll get back to the video. Alright, so here's our Pelican Air that we talked about, and if we open the lid, see, I took the majority of the foam out that came with it, the peel and plug foam, but essentially what we want to try and accomplish is mounting a monitor up here and mounting the remote control panel units here. So first and foremost, when we go to mount the monitor, the lid depth is about 2 inches, and the monitor itself is going to stick out about 3 inches. And that's just because of obviously the width of the monitor, but also the BNCs that we have to stick out the back here so that we can get our shading video actually into here so we can see the cameras. So ideally we would want to mount this with some sort of mount, maybe an arm that's as low profile as possible so that we can still maintain the most shallow depth possible. But essentially that would mount there, and that's going to be super distracting, sorry, with the glare coming off of that, but that would mount there. Now the challenge is, because of making this functional and operationally pleasant for the shader, we want to be able to take our remote control units and keep them at least relatively level up here so they're not killing their wrists coming down here and doing the controls. So what I wanted to do was find some sort of a concept that we could mount these in a way that they could have a little bit of an angle to them up here where they could still see the monitor and do the control knobs and everything like that. So unfortunately you just can't, hard mount that there, the lid would never shut. So instead we need to make some sort of a hinge system so that we can store this. And we're going to draw inspiration from none other than this empty keyboard cardboard box, because it essentially has a hinge system at the bottom and a hinge system at the top. So our concept is this would be essentially kind of sitting or mounted somewhere down here at the base. And of course the measurements aren't going to be exact for this, but it would be able to rise up to this point and then have the additional hinge here to mount the remote control panels to. So sort of what that would look like is if this would be mounted to this point here, it could come down to the base to store so that it can clear the monitor, but when you're ready to use it, this would hinge up to the top here, and then this would be able to hinge up to get the angle that you want. Now, of course, like we said, this is a little large there. More realistically, what I would want to do is, again, to see it come up to this point. So it would essentially fold up on this bottom hinge to this point, and then fold up so we could get the angle that we want for the operator. Then, when everything's said and done with, once this is all put together, we would make it a little nicer by running all of the I/O to the back, where we have some switchcraft feed-throughs for our BNCs and other things that we could essentially just kind of mount on the back here, and maybe even put a little protective lip here, just so we don't accidentally knock it silly. So another thing is, I just wanted to share this little diagram that I put together of the overall project, and again, how I'm kind of expecting this to work is within the box itself for wiring. You can see the AC power coming in from the left-hand side of the box, which is going to run into the power brick for the Marshall monitor, which is going to, of course, power that. You see the 5 remote control units lined up with their cables coming out and going into the back of the Pelican case, which will be fed through. And then, of course, the 2 SDI lines that will be coming in for the shader monitor. All right, so now that we have a little bit of idea of what the end goal is going to be, I need to go get some parts at Home Depot, and we'll see you right back here in just a moment. All right, we are back from first shopping trip, and we got a few parts here that we think are going to do what we need them to do. First of all, hinge-wise, let autofocus take this. We got some bifolding door hinges, which I think is going to be exactly what we are looking for here. As far as for the plates and everything, to keep this alight, I was thinking of using just standard RU plates and attaching the hinges to here. So we got a 6 RU plate down here in the bottom, which will be really nice to fasten that directly to the bottom to give us a good base. But then the concept is we'll take these hinges. So if you imagine this bottom one is going to be attached to the base plate there, and then these guys we can put on the edges here, which will give us the up portion that we need to get these to the top here. So if you imagine this being sunken a little bit deeper, it's going to get us the up portion. And a 3RU plate here is actually just the right height we need to get up here to the top. So then we got another set of hinges here that we can essentially tie to the top of the plate, and then be able to hinge up the actual remote control panels. So that's going to be the concept, and what we're going to do is we're going to try and put all these hinges together and see where it leaves us. So admittedly, I'm not the best when it comes to using power tools. So instead, I enlisted our own resident master craftsman, John, to help with this part. And throughout this, you're going to see us putting together and constructing the box overall. And during this time, I thought it would be a good idea to just give you a little bit of basics of what a shader is. To understand what a video shader or video operator's role is, you need to first understand why their position is important. Firstly, when you think of a standalone camera, you think of a camera that has its own independent controls for iris and black levels and white balance and everything like that. in which case your camera operator is usually responsible for controlling those things while they're at their camera. So typically in a broadcast environment, those controls of the camera are extended back to a remote location where another individual is controlling those functions, so that the camera operator can focus on operating the camera and somebody else can split the workload of making the actual changes to the composition of the picture. But a video operator's role doesn't end there. In a multicam production, it's important that the composition of all of your cameras match each other so that it's not jarring when the technical director is cutting between cameras. When the technical director is cutting between cameras, you want the composition of each camera to be as close as possible so it looks like it's all one congruent image. It's because of this job function that the video op is typically able to see all the camera feeds at once, or at least be able to switch between them easily. Now I know that's a very simple overview, but I do plan on making a future video for broadcast cameras in a multicam environment, so make sure you keep an eye out for that. Alright, now it's my turn. Now that we get the box completely constructed and put together, it's time that we take an actual look at the RCUs, the remote control units, and see what we can do to adapt them. Alright, so here is one of our remote control units, and let's open this bad boy up and see what makes it tick. So again, ultimately, what I want to do is find a better way than using the mini DIN 6 connector here, because again, this isn't very common in the feed-through world. So I want to see what we can do as far as adapting this to DB9. Ideally, again, like I said, I want to try to preserve this cable. So I'm going to see how exactly this is connected on the inside. Alright, so now that we got this open, we can see that our DIN 6, mini DIN 6 connector is coming in here into this little guy. So what we'll do is we'll detach that from the board. There we can see our connector here. So that is essentially what we need to find. Alright, so after extensive Google searching, what we determined was that this connector under the CN8 is actually a JST PH 2mm connector. 6-pin, of course. So, scouring, we were able to find this. So this is going to be the exact fitting we need with 6 pins and 6 fly leads. So this is what we're going to use to adapt to our DB9 connector. Now the next thing we're going to have to do is come in here to the original cable and trace this pin out here, trace this pin out to here so we know exactly which one is going to be which. We're going to use a multimeter for that. Alright, so here is our multimeter. You can see it's set to ohms. You can see we have an open line right now. Closed line, open line, closed line. So with this, we're going to be able to test the continuity of our cable and trace out the pins. So again, I have the actual pins located here from the documentation of the remote control unit. And we're going to figure out what these are and maybe make some notes. All right, so I just want to give you guys a little bit of an idea of what we're shooting for here on the electrical side of things. So on the left, I have a diagram that I've put together of our breakout cables that go into the remote control units and their pinouts and colors. So the original is going to be based on this guy here, the original cable that came with the remote control unit. And then we have the new one, which is based on the same pinouts, but with the colors of our new ribbon cables. So I do this just so I don't get confused moving forward when we actually go to set this up, so we make sure that all the pins are one and the same and correct. So what I'm gonna end up doing is, because these are way too short for what we need, is I'm gonna have to extend them. And I'm going to do that by using this wire here, this 26 gauge wire. And unfortunately, I don't have every color to match this wire here. So you can see under the new, we have our black, we have our red, we have our white, we have our yellow and green, but no orange. So I'll just have to use the blue for that. And then I'll make a annotation there on the diagram that that's what that's going to be. So on the right hand side here, we actually have the pinout brought up in the telecast manual. So this is a specific cable that you can actually buy from the manufacturer, which is what we had originally done. And that cable looks like this. So it's got our DB9 here, and it's got our mini DIN 6 pin connector here. And in this diagram, you can actually see that there is quite a bit of sorcery going on here, where a lot of pins are being either jumped or tied to shielding, and then also on the 6 pin. So unfortunately, I can't really take the female mini DIN 6 apart. Let autofocus take care of that. Right? And again, I don't really want to brutalize this cable, and since we already bought it, I want to utilize it as much as possible. So what we're going to be doing is essentially keeping this cable connected to the camera control unit and running it out as standard mini DIN 6. And then what I did is I ordered some straight through mini DIN 6 male to male cables. So what I'm going to do is I'm going to end up cutting those apart and then taking those leads and building my own little adapter cable to adapt from mini DIN to the appropriate DB9 that we need. So another thing I want to try and take advantage of here is, if you look at the front of the remote control unit here, you will notice a preview button. And the purpose of this preview button is when the operator holds it down, it essentially would change the camera source that they're previewing in their monitor to this particular CCU, in this case camera 1. So this actually sends a GPIO out of the back of this guy that you would typically run to your video switcher or whatever, device is changing that source preview. So if we look at the back, your terminals, this is going to be your ground, and the one on the right is going to be the actual preview voltage, which is standard +5 volts, and then when it's held, it goes to a negative. well, not negative, but 0, 5 to 0. So effectively, I want to take advantage of that. Now, typically you would have your own independent cable running that. So what I want to do is piggyback on the DB9 cable, because we're only actually using 6 pins of the DB9 cable here. Well, technically 7 if you count the jump here, but pins 5 and 4 are not being used. So what I want to do is use pin 5 and 4 in our DB9 cable to carry that voltage, that +5 and the ground, and then once we get back to the fly pack, we'll break that out and run it independently to the switcher. So then, just to reiterate all of that, I put together this little diagram just to show you kind of step by step essentially where we're going with this. So over here we have the Pelican case and we have the remote control unit. We have our 6 wires coming out of our connector off of the circuit board and coming out into its own cable, as well as the 2 GPIO cables that are going to be part of that cable, and they're all going to terminate into that DB9 male. That of course is then going to attach to the feed through that we're going to put into the back of the Pelican case. And then from there, we're just going to use a standard out of the box female to male serial cable, DB9 pin. And then that is going to attach to the feed through that we are going to install into our fly pack. Now on the other side of that, we're going to have our adapter cable that we're going to make up. That's going to be the DB9 female. And from there, it's going to actually break out the 2 GPIO cables, and they're going to run down here into the DB25 male, which will eventually plug into the Rave Audio breakout unit, which is just an extension of the Ross Graphite production switcher. It's essentially where the GPIO connector is. Then when we come up to the other side of this adapter cable, it'll be our Mini DIN 6 male that we are going to essentially tie to this DB9 female connector. And then that adapter cable is going to plug into the original manufacturer's cable that was the Mini DIN 6 male going to the DB9 male into the actual camera control unit. So remember, the initial cable was straight out of the remote control unit Mini DIN 6. So that would connect directly into this cable, the manufacturer's cable. So that would have went directly into this. So that's essentially what we're trying to do here is we removed that cable from the remote control unit and we are making our own replacement cable, which we are going to make nice and short, and we're going to run into the feed through and then extend it over DB9, and then in the inside of fly pack make the adapter to adapt it back to Mini DIN 6 so that we can reuse the manufacturer's cable. Alright, so this is essentially where we are going with this. We are extending each cable, and also note our orange to blue right here, our one color difference, and we did make an annotation of that, so we're good to go. And now we're just going to heat seal these solder connections and be good to go. So the next thing we need to do is actually is going to be to include the other 2 wires that we need in order to create the GPIO for the preview button. So I cut to length a same gauge wire, green and red. Green will be our ground, red will be our voltage. And we're essentially are going to incorporate this into the cable, because remember that these guys are going to be what's going into our terminal block in the back here. So we will actually put on some fork connectors onto these so that we can easily screw them down into the terminal block. So my next step is going to be to actually make a cable out of this. So for that, I have some shrink tube here that I'm going to feed all this through and make a nice good cable. So again, here is what I essentially want to accomplish with this. Is again, this will be in here, right? And then these two leads coming out, we're actually going to put them on their respective terminals like this. Now we'll have to leave the original plate off so that we can get them through here. But I think this will work. I think this will be exactly what the doctor ordered. That way it all gets carried through the single cable and we don't need to worry about anything externally happening here. For the two leads of the cable that are going to be carrying our preview GPI, we're going to be putting on these two little crimp connectors that are going to essentially be used then for the screw block terminals that we see here. So I adjust the focus, right? That's going to be going on there. And this will just be, very simply strip the wire back, put it on, crimp it, so that ultimately the end result is going to look like this, right? All right, so with all of our wires completed, we are now ready to start assembling the boxes again. So we have right here one of our cables, and again, we can see all of our terminals are ready to go. And we're gonna pull it through here. We're gonna come down. And again, we wanna do this before we actually terminate the end of this cable into the DB9 connector, because otherwise we'd probably struggle getting it through that little hole. So we're gonna bring this in just like that, right? One additional thing that I would really like to do is to put a little bit of strain relief on this cable. Because right now there's not going to be anything holding it here in place other than the remote control unit itself, and we don't want to have that, accidentally pull too hard on the connector that's into the circuit board. And I don't want to reuse the ones that we had in here initially, just because it's going to be a bit of a different size gauge, and I don't want to risk crimping the cables too much. So instead, what we're going to do is we are going to use little zip tie adhesives. So the goal is that we can put this right on the side here. Actually fits just perfectly right there. Right? Let that get focused, and then we can actually zip tie this to the side here. And that'll be our strain relief. Now the only other thing I want to do is, because we're not reusing that, this edge is, I don't want to say sharp, but it is an edge. So what I'm also going to do is I'm going to take a little gaff tape and just put a bead around this, around the cable, right where that's going to be coming through, just so that it has a little bit of extra buffer between that and the edge, so it's not potentially cutting into our cable as it goes back and forth in the box. And there we have it, the completed side of this part of the box. So we got everything put together here nicely, and now we just need to terminate this to a DB9. again, what we're going to do is we got this mini DIN 6 cable that is built for straight through, and we are going to cut this so we can get the end, and then we're going to have our leads here, and we're going to pin them out, and then we are going to take those and put them into a DB9 female. All right, so now that we got our pinout identified, we are going to take this and we are going to take our female DB9 connector, and we are going to just simply take these, put them into their respective pins, and then see if this all works. So one additional thing I did just want to mention with these cables, of course, we are wiring this for our GPIO as well. So I did add these two leads here. These are two 18 gauge pieces of wire, and they are of course going into the pins 9 and 7. And these are just going to be free leads that are coming out right now, and we are eventually going to put these into our DB25 pin that is going to go into the production switcher for our GPI. All right, now that all that is said and done with, we are here at the moment of truth. We're gonna put all of this together, plug everything in, and make sure that it all is working. So we of course have our remote control unit that we've adapted to our DB9. We have the original manufacturer's cable, which is mini DIN 6. And then we have our illustrious adapter that we have built to go in between with our straight through cable. So as you can see, we of course don't have the GPI portion of this configured yet, just because it's going to be a lot easier once we have the rest of the cables made, and they're all going to eventually go into the same DB25 connectors. So yeah, we'll do that later. I'm actually more just interested in whether this is going to work or not. You know, the GPI stuff is pretty straightforward, so we can always test that later. So here we go. We are going to plug this together, put our adapter in the mix, and this is the camera we're trying to control, by the way. So with this plugged in, this should start lighting up, which it is, that it is booting and it is taking control of the camera, and there we go. So we should have all of our functionality here. So when I go and press this, I should be able to invoke color bars if I need to. I should have my iris control, which we do, and our black level. Perfect. So yeah, everything seems like it's working great, which means we can just go ahead and keep manufacturing these cables, these adapters that we've put together. And you know what? Why don't we test the GPIO voltage as well? We can do that here since we're all set to go. So we're going to put our multimeter to DC voltage, and we got our leads here. So if all goes correctly, when we tap the preview button, this should go to 5 volts. Make sure I got a good hold on these, right? So we'll tap the preview, and there it goes, 5 volts. When the preview is held, and we pull it off, and it goes down, and we press the preview, if it will cooperate with me. Press the preview, and there it goes, 5 volts. And unpressed and depressed and 5 volts. Perfect. So we know the GPIO is going to work too once everything gets put together. So With that in mind, I will be right back. I'm going to go manufacture the rest of these cables, and then we only have yet to put them into the Pelican case. Hi, Future Ryan here again. So, full disclosure, that definitely did not work the first time. I ended up having to go back and troubleshoot and found out that my pinouts from the original cable were absurdly wrong. So I'm going to put up on the screen right now the actual pinout. But after going back and fixing the cable, everything did fire up correctly, which is the clip you just saw. Would I have liked to have gotten it the first try? Yeah, but no one's perfect. And there we go, 5 remote control units all wired up and ready to go. And also keep in mind that this part of the adapter is going to be going into the fly pack itself. So really this portion here is what's going to be connecting to our box. This will go somewhere else, and they will be connected by a serial DB9 cable in between. So now that we got these all tested and built, let's go ahead and put this Pelican case together. So after we got the box all put together, it was then time for me to turn my attention back to the GPIO cables. So in here, you're just going to see the 5 adapters being run into the DB25 into the correct pins, and also me tying the grounds together. In the end result, one completed adapter cable ready to be installed into the fly pack. The only thing left to do is to take the DB9 switchcraft feed-throughs and install them into the rack plate, and then install that with the adapter cable into the fly pack itself. Alright, so here we go. We are now in the back of the rack itself. You can see we have our 5 DB9 connectors that we secured in here, and our adapters that are coming through. So the other end of this cable is going into the back of this, which is our rave breakout box, which is just part of the graphite. It's on the back of here is where the DB25 GPIO pin cable goes. So there it is. That's essentially all we have here. So the DB9 serial cable that's coming from the remote control units, from the shader in a box, will plug directly into here, and we'll be good to go. So I didn't really know if I should include this part or not, but this is actually me configuring the GPIOs in the Graphite production switcher. Keep in mind, this is going to vary wildly depending on the switcher that you would be connecting this to in terms of how you do this. But I'm simply going into each pin in the configuration menu and setting that to receive GPI as opposed to a GPO, right? A general purpose in, as opposed to sending a general purpose out. and essentially each one is just going to change a cross point on an auxiliary bus, in this case auxiliary bus 6, so that when you press the preview on the respective remote control unit, it's going to select that particular camera cross point on that particular aux bus, which that aux bus is what we're going to be feeding our shading monitor. And here we are at the final moment of truth, the moment you've all been waiting for. Does it work? We have just plugged in all of the DB9 cables into our feed throughs on the back of the fly pack. Looks like all of the remote control units have booted up. I put bars in the aux 6 so we can see it switch when we do this. And if everything goes according to plan, we should be able to preview each and every camera through the GPIO and then take control of it through the remote control units. So here we go. Camera 1, preview. Changes the aux, great. Do we have control? Yes, we can iris, we can black, we can do all things. We can do color bars if we need to. All right, so let's move to camera 2. Let's preview camera 2. There we go. Great, got control. Camera 3 preview, changes, and control is good. And camera 4, preview, looking a little dark. Let's iris that up, looks great. And camera 5, preview, very dark. Let's iris that up. Maybe a little less black, maybe a little more black. And there we go. Everything is functioning according to plan. Everything looks great. And there you have it. And I think that'll wrap it up for today's video. Thank you all again for watching. If you found this video useful, make sure you like, share, and subscribe. Let me know for sure in the comments if you like this kind of content, and if you do, we can continue to do more projects like this. But until then, we'll catch you next time right here on Broadcast Buddy TV.